Hi, hello everyone. I think audio and video, everything is clear. Quickly confirm in the chat. Yeah, cool. Okay. So, a thumbnail, you have power electronics. No, it's about machines. Okay. Induction machines. So, we'll discuss some basic questions the way we do, but we'll see the, what to say, little deeper analysis or inside. We'll build the concepts with the help of those basic questions. Okay. I hope all of you ready for that. Let's get started. Okay, cool. So let me just scroll through the questions what we have in the session. So then we'll jump in. Okay, what happened? Yeah. So here are the questions. Some are easy questions. Some are little interesting questions. But whether it is easy or little deeper, we'll analyze every question. Okay, answering is not objective. Analyzing is objective. You know that. So yeah, basically we got 20 questions in this session. Yeah, that's it. That's 20. We quickly scroll through those 20. Let's get started with the first one. Back. Yeah, your time starts now. Get ready. Try to answer. Quickly, just options. You know, right? Oh, we already got the answer. First blast. Okay. For the first answer, who is that? Lokesh Kumar. The blast is for you. Quick answer, first answer. Let's see whether it is correct or wrong. Yeah, it's correct. Easy one. Everyone answered it. Everyone answered the same. Everyone answered it as C. Amazing. Okay, so it's good to hear that. Good to see that. Okay. So I think we don't have to wait for a minute time, right? Almost everyone answered it already. Somebody saying A. Praveen Yadav, by mistake you pressed A or just you wanted to check, that's why you pressed A. Anyways, time's up. So let's see this. What we have here is principle of operation of three-phase induction motor is most similar to obviously three-phase induction motor induction principle, and is the same as not synchronous. Synchronous motor will rotate at synchronous speed only, but this rotates at which speed? This rotates at which speed? Tell me. Three-phase induction machines rotate at not synchronous speed, asynchronous speed. Okay, it can rotate at any speed, but not synchronous speed. Okay, so that's what is called as asynchronous speed. Maybe less, maybe more. Yes, I mean it. You can rotate. Yes, still you can call it as a motor. You normally know if the speed of the rotor is greater than synchronous speed, it will work as a generator. That's what a regular induction motor, but there is some special induction motors. You can still operate the induction machine as a motor even beyond synchronous speeds. Okay, that's a really creative motor. That's what we use in case of windmills. Okay, that's what is called as double fed induction machine. Okay, anyways, moving on. That's the synchronous motor, and there is asynchronous motor, which is pretty much same as your transformer. Okay, but in case of a transformer on the secondary side, careful with this point. In case of a transformer on the secondary side, you will be connecting some electrical load. Some electrical load, you'll be physically connecting it. But in case of induction machine, induction motor, the rotor side, rotor is a secondary. It's a kind of a secondary. In between you have air gap as a medium. Through air, flux is linking. Okay, but in case of a transformer, you have a continuous magnetic path, same magnetic circuit, common magnetic circuit. Okay, so secondary is short circuited. You can treat like that because rotor windings are short circuited. So hence you can call it as transform with a shorted secondary is similar to this three-phase induction motor. I think all have done good. Okay. So we got something. Meanwhile, go to the next questions or what happened to the previous style of teaching. That's projector and all. Yeah, what do you want? You want to bring that? So we have everything. Okay. We have the projector. But there also I had problems with the lights and all. That's holographic projection concept. It's projecting straight into my eyes. Okay. But here also there are a lot of lights in here. That's also the same problem. But yeah, we do have that facility. Okay. But for me, this is more comfortable, it seems. Yeah. I think Praveen, don't you like this? When you're not enjoying this, then why? Principle of induction motor is also similar to synchronous motor. Praveen, that's absolutely not right, dear. There is a principle of operation of synchronous motor is completely different. It works on magnetic locking principle. Okay, but induction motor will never work on magnetic locking principle. There, in some Lorentz force will come in case of induction. In case of synchronous, attraction force due to the magnetic locking will come. So there is a huge difference. Okay, so I hope you are clear what we're trying to say. Anyways, of course, yes, but previous method one is too good. Yeah, I do know that. Okay. Anyways, moving on to this. Moving on to this specific one. The two primary, see, primary means don't think that primary winding and secondary winding. Okay, most of you answered correct, but some people are saying stator and field. What is field here? Tell me. Those who are saying field, the stator itself is a field winding. Careful with this point. The stator itself is a field winding. Okay. The reason why we never discuss armature reaction case of induction machine. That's one of the interview questions. In case of synchronous, we'll discuss about armature reaction. In case of DC machine, we'll discuss about armature reaction, but not in case of induction machine. Why? Why? Because the armature winding and the field winding both are stator winding only. Field winding means what? Where magnetic field is produced. Because of what? Because of the stator winding. Okay, working current is flowing in the stator winding. So both the windings are carrying that. That's why we never discuss anything called armature reaction. Okay, in case of this induction machine. I think that point is clear. Stator and field, they are stator itself. Okay, both are stationary. This is a part of field is a part of a stator. So to be more precise, the key, it's not primary means, I think you must have misinterpreted this. Primary means you might have thought it as first winding, like transformer primary and secondary. So that interpretation of the question itself, you failed. Okay. Primary parts, the key parts, that's what it means. Okay, so you have to understand that a little tweak nicely. Okay, I hope by now you got it. Let's move to the next one. Keep it up. We got kuch acha ho raha hai. Some nice responses. Yeah, that holographic projection and all, that you will never see anywhere. Okay, that's I got inspired from Iron Man movie to be more precise. We worked for 2 years. After 2 years, because I saw Iron Man movie there, moving and all these things. That's really crazy, right? So I instructed my guys, and they did it amazingly, surprisingly. That's all a different story again. So people have that glass, but not projection. That holographic projection concept is not there with nobody. Only PiSquare. Let's like for that feature. Yeah, bang, man. What a response. Amazing response. Every 100% of the options are C. I think it's really good. It's really good. It's really energetic. Okay, such responses will make it more energetic session. A simple question, that's why you're doing that. But here, what to learn? What to learn? Key point to learn. The key point is, in a rotating machine, the generated EMF, key point I'm saying, beyond what you know. Okay. The generated EMF always induced EMF or generated EMF you can call. This always lags its corresponding flux. Approximately, ideally speaking, it's 90 degrees. Okay. So this is not only true for AC machine, it is true for any machine. Any machine you take, flux is suppose somewhere its corresponding induced EMF. If the induced EMF is, remember this point, if the induced EMF, we will see such interesting points in this, some conclusions which you need to carry forward. Any induced EMF will lag its corresponding flux by 90 degrees. Okay. So if the circuit is resistor circuit, current also is in phase with this induced EMF. Any induced EMF, if the induced EMF is due to Faraday's law, it has to lag by 90 degrees. Take a note of this key point. Okay, we'll see such key points here. I think it's clear. So EMF induced is lagging the flux by 90 degrees. Everyone mastered it. Okay. But I think you got that point also. It's not only true for this, for any machine. You name a machine, Faraday's law of electromagnetic induction means 90 degrees flux and induced EMF. Flux with corresponding induced EMF. Okay. Anyways, it's clear? Anything further to discuss on this? No, right? Good. Okay. Let's move to the next one then. So we got something for this. Let's handle this as well. Praveen, what happened to you? It's been a long time since you're back. We had another Praveen in the previous sessions. I thought it was you. But now I saw your full name. I got to know it's you. So we got Santu music added today. Praveen, I think, is also new. Pramila is new. Sweetie RK YouTube channel. That is good. So yeah, time's up and we got cool answers. 27% of people are saying D. It's okay. Fair thing. Now let's see what is this. What to learn in this. The effect of increasing the length of air gap in an induction motor will increase what will increase? Air gap flux. Sorry, length of air gap. Length of air gap increases means, flux is equal to, come on guys, this is a key concept. Simple basic Ohm's law. What is a magnetic Ohm's law? What's that? Magnetic Ohm's law. Flux is equal to MMF by reluctance. Let me tell you one key point here. The key point is MMF is represented with F, right? And reluctance is represented with S, right? I said this is magnetic Ohm's law. Let's see electrical Ohm's law. I is equal to EMF by resistance. MMF will represent with which letter? Tell me in the chat. EMF is represented with which letter? I want everybody to respond for this. Which letter? Huh? Yes. Letter E. What is the next letter to E? Next letter to E? I think everybody knows that. It's F. See here, EMF, MMF, next letter itself is F. Resistance we represent with letter R. Reluctance will represent with next letter S. See, such an amazing thing, dear. You're not knowing so far. Lot of such amazing things. Even the naming that F, S also has a key point, which you never know because nobody taught you. Okay, and you never read books. That's natural. I'm not talking about a voltage. I'm talking about EMF. EMF, MMF. There is a synchronism in this. So this is electrical Ohm's law. This is a magnetic Ohm's law. So now, according to this magnetic Ohm's law, MMF F is equal to N into I. So if length of air gap is increasing, reluctance increases. So to have the same flux, MMF has to increase. For the MMF to increase, you have two options. One is N. N means, is it speed? No, number of turns. So if air gap is high, motor should take more windings, should wind more turns on its own. Is it possible? No. Number of turns is a design factor. At the time of design, you can do that. Motor cannot do by itself. Then what is the leftover thing? Current. It will draw more current to have the same flux. Now you may ask, sir, why? How it is knowing that it should have same flux? Equation says I am stating that same flux. But how the motor will know I need to maintain same flux? How the motor is knowing? It is knowing because it's from the voltage is fixed and frequency is fixed. If voltage frequency is not changing, V by F is a constant. If V by F is constant, flux is constant. Remember this point. Throughout AC machines, V by F is a key thing. Okay. If V by F is constant, flux is constant. Flux to maintain constant. If this is increasing, this has to increase. So for that, it will draw high current. Which current? This current is responsible for increasing the flux. So hence it is called as a magnetizing current because it helps in magnetizing. Okay, so magnetizing current, the lovely name. Okay, I think we're good to go. Let's go to the next question. Any clarification on this? Yes, Sweetie RK YouTube channel is saying it reduces the power factor by increasing this magnetizing current, which means power factor is poor. Absolutely right. Absolutely right. Okay. Nice. Suresh is doing good. Raju, what happened, Raju? There is a delay in your response. It's okay. It's okay to have a little delay in your response, but it should be correct, huh? Don't try to be wrong. Nice. Santu music. What is Santu music? What are you doing? Read the question once again, dear Santu music. Sheikh is right. Anyways, time's up. So we got pretty decent answers. If not, all are correct except the Santu. Everybody has done pretty good job. Okay, I think Santu is missing something maybe. Let's try to clarify that point as well. Nothing to worry. So it says, what's the main reason why the rotor of an induction motor runs in the same direction? I have performed an experiment. I think in our course it is there, induction machine course it is there. That experiment, how the torque is produced, I have designed my own rotor. Okay, induction rotor in our laboratory in our research lab, we developed a rotor, which you can also do it. And it just with conductors, just the way it is, it's a squirrel cage kind of a thing. I think in the video it's there. So we placed it there and we saw torque, and that rotor, what we designed, it is rotating. Okay. And it is rotating in the same direction as the rotating of the stator magnetic field. And this RMF concept, believe me, I don't think one ever done that simulation and result, the traveling waveform, rotating magnetic field or traveling waveform. In YouTube itself, it's there. Okay. So how the pulses are, how the voltages, different voltages are changing. If all three voltages are changing, how the resultant MMF is traveling in the space. I think that simulation results are there on YouTube. You can search in PiSquare YouTube channel, you will get that RMF concept. So, and you must watch that, because there that's a real-time simulation result. So we change something. What if the windings are not 120 degrees or the unbalanced voltages are there? Then how the RMF will be, we'll clearly see the picture. Okay, and you can even download that animation. You can play it yourself as well. Okay, try that. It's interesting. And now, as I said in the previous question, synchronous motor, it's a locking torque. Okay, in case of induction motor, it's the force, Lorentz force exerted. Okay, so Lorentz force exerted, it will try to drive, even in case of a transformer also, the direction of induced EMF, that is decided by the Lenz law. Okay, in case of your transformer as well. Here there is no different. Here also it's same. The direction of their induced EMF will call. Here the final result is, it's the torque. Okay, so that also depends on the Lenz law. Okay, because the force is due to the Lorentz force and the direction is based on the Lenz law. Okay, yeah. And you may say, sir, why not this? Can't we apply, if it is a motor, we know we have to apply Fleming's left-hand rule. Can we apply Fleming's left-hand rule? Can we find out the direction of this by using Fleming's left-hand rule? Yes, you can pretty much find out that. Okay, but the simplified version, if you end up in taking this Fleming's left-hand rule to find out the direction, yes, you will get. But this is a much easier version of finding out the direction. Okay, simple concept. It will always try to oppose the cause of creating it. What is creating it? The relative speed is creating the cause. So to reduce the relative speed, motor has to pick up the speed, and it is going in the same direction of the RMF. So relative speed between these two are reduced. Lenz law is there. Okay, so yeah, next one is inverted induction motor rotate in opposite to RMF. Inverted induction motor, it's basically braking mode. The same induction motor under braking mode. Okay, if you are naming it as inverted induction motor, it's okay, but it's a braking mode. In the braking mode, definitely it has to rotate in opposite direction. Okay, opposite direction means both directions are opposite, hence the slip is higher. Okay, wow, good, keep it up. So far we got a couple of series of right answers, but we just deviated a bit. I mean, some people are saying D and B. It's okay, let's see. Okay, time's up, by the way. Let's go for this. The rotor of an induction motor cannot run with a synchronous speed because, yeah, just now we have seen, if it is running at synchronous speed, there is no relative speed. Suppose a rotor is trying to catch that, try to maintain zero relative speed. Suppose the moment relative speed is zero, means the moment rotor catches this stator flux, the relative speed is zero. If the relative speed is zero, no Faraday's law, no induced EMF. If there is no induced EMF, no torque, so motor will try to come back. Okay, Again, the moment it is back, there is a relative speed, it will try to pick it up. Okay, so always it will follow. I want to follow. It will follow the stator flux. It will never catch that stator flux. But if it catches, what happens? The rotor torque would then become zero, because rotor induced EMF is zero, hence rotor current is zero, hence rotor torque is zero. Everything is zero. I'm talking about SRIM excited by the rotor side. That's what double fed induction machine. SRIM excited by the stator, rotor side, and stator is short circuited. Okay, that's what inverted induction motor you're calling. Okay, so there, yes, it will rotate like that. It will rotate in opposite direction. But that's what one of the interview question. Even one of our student, he went to BARC interview. He called and asked me for this, because in the interview panel they were asking this question, like exactly this question: if rotor is short circuited, if rotor is fed to the supply and stator is short circuited, what will happen? That's also discussed in our course as well. Yeah, this is also one of the interview questions. Okay, next one. I think this is also easy one, which everyone should be able to answer this. Okay, let's see. Mark your options. Come on, what are you doing? Fatafat, taratari karun. Just a button. You need to press option A, B, C, D, whatever you like. Okay, whatever is right, whatever you feel right. So check that. When you're marking it, you will get to know. Nobody is going to complain you. Nobody is going to deduct your marks for marking wrong answer right. You will know yourself, okay, I thought this answer, but this answer. It's for your own clarity. Okay? Don't worry about being wrong. So if you keep worrying about being wrong, you will never succeed in your life. Okay, be wrong, correct yourself, know your mistakes, learn from there. That's only it will work. That's how the life goes on, right? Good. That participation will, spark your brain to focus on the answer also. It will help in a lot of ways. Time's up. Good. Why I'm saying good? Because we saw amazing response for this question. Okay. So for that, that's a blast. Okay. Okay. Now I think mostly people are saying option A. Some people are saying option C. Okay, fine. Yes, absolutely right. Option C is correct. Rather, 4 to 5% of the full load current is correct if it is a transformer. If it is a transformer, the no load current is 4 to 5% of full load current. Now, in case of induction machine also, it is same, because a transformer induction machine is same, right? So for induction machine also it should be same. Am I right? No, it is not same. Why it is not same? Just now in the previous question I said, because of the air gap between two circuits, between two windings in transformer, there is no air gap. Completely filled with one common magnetic circuit, which is of good permeability. Okay, but in case of induction machine, it's a rotation, right? If it is a rotation, you cannot keep the stator and rotor intact together like this. You cannot attach them. If it is attached, you cannot rotate it. Friction issues will be there. So you need to maintain some gap. Try to maintain less gap, but there is a gap. That gap itself will draw huge amount of current. We saw that. That's one of the reasons. There is one more reason why it has this much. Answer is this. One of the reasons is air gap is one of the reasons. There is one more reason why no load current is high for this induction machine. What is that reason? Tell me. Air gap is one of the reasons. Very good, Sampath. But there is one more. What is that one more? Yes, I'm expecting from somebody who is answering option A. Yes, come on. Amazing, Raju. Rotational losses. In case of a transformer, there is no rotational losses. Transformer is a static, mechanical losses are not there. No friction losses, no windage losses. But in case of induction, it is there. That is also part of a no load loss. Yes. Somebody has to supply that no load loss, right? Who will supply? The stator only is the supply only will supply. I mean, the input only will supply. So that's the second reason why this will be in the range of 40 to 50% normally. But yeah, a little bit of exaggeration here. 45 to 50, it's okay. But not 70 to 80% after all, okay? So yeah, this would be the right answer. I think everybody got clarity on this. Rotor conductors are short circuited. Okay, I think we got an idea on this now. Let's move to the next question then. Timer is running. You're responding nicely. Good. See, now your mind knows, okay, I thought this is right, but this is right. You know, that my answer is wrong or right. You got a better clarity on that. Okay, so try to participate. You know, I'm not asking you to type a lot of big answers because the system we have designed so that it should be easy on you to mark your options. And you can see the response, how other people are responding. You don't have to look at the chat. The tool itself, the AI tool itself is giving everything to you, right? So, did you ever see these kind of tools anywhere on YouTube live sessions? No, right? Then participate, enjoy, have fun, and learn definitely. Not just having fun. Learning is a key thing. Okay. Good guys. Loved your response. You know, next three questions are going to be little tricky ones. Let's see how many of you answered it correctly. Okay. So yeah, I think time's up. Okay. Let me just give this. In a three-phase induction motor, the relative speed of a stator flux is zero. Key point here. The relative speed of stator flux is zero with respect to. I told you one point in DC machines. The point which I said in case of DC machines lecture, concept MCQ video. I said one key point. The key point was for the torque production to happen, for the machine to rotate, either generate electricity or generate mechanical energy, whatever, you need how many fluxes? How many fluxes you require? You require 2 fluxes. For any rotating machine, you require 2 fluxes. Okay, most of the cases. There are some exceptions, of course, if it is a reluctance motor. There are some exceptions for cases, but most of the cases, that's not the case. Okay, for most of the cases, 2 fluxes must be there. And both the fluxes must be stationary to each other because the torque formula, what we said, torque is proportional to phi1, phi2 sine lambda. This is a formula. That's a torque formula, right? So phi1, phi2 sine lambda, this lambda must be constant. Careful here with this point. This lambda, for any machine it is true. This will help you a lot in case of measurements also. Okay. So the application, basically the application of your machines is measurements over there. In measurements, you will see this. See, if suppose this lambda is not constant, why lambda will not be constant? What is this lambda here? Lambda means, lambda means the angle between phi1 and phi2. Angle between phi1 and phi2. So, this angle, if it changes, suppose if this angle is changing, means what? Both are not stationary to each other. Phi1, phi2 are not stationary to each other, means both phasors, let's take it as a phasors. There is a speed difference. They are rotating at different speeds. Phasor diagram if we talk about. Okay. So the angle between phi1 and phi2 will keep on increasing. Again at 360 degrees, again it will keep on increasing like this. This will be the lambda. If the lambda is this, lambda shape is like this is lambda. Okay. If lambda is this, then the torque will be, how will the torque tell me? Torque will be nice sinusoid because sine lambda is changing from 0 degrees to 360 degrees. So you will get torque, sinusoid torque. So what sinusoid torque means? The average torque is 0. Instantaneous torque is sinusoid. The average value of this torque is 0. So machine operation is not possible. No machine. Okay. And that's the reason why synchronous machines are not self-starting, because there your rotor field is a constant field. Stator flux is rotating at some high speed, synchronous speed. So the lambda is changing continuously. Hence the torque is like this. Average torque is 0. Okay. So that's why you need to give some initial torque, initial rotation for the synchronous machine. Okay. I think the points are clear. So these two must be present for any machine to operate, and they must be stationary to each other. Okay. So it is said here in this, let's come to the question now. The relative speed of the state is 0 with respect to the rotor flux. Simple. You don't have to look at the options. The answer must be the relative speed of the stator flux. Means let's talk about phi1. Phi1, phi2, there should not be any speed difference between these two. There has to be in the same phase. Okay, they must be in the same phase. I think it's clear. So option is rotor flux. Option is C. And most of you marked it. I think now you know the real logic also, not just the answer. Now you got a clarity on how you should handle that. Okay. And about this torque changing, this lambda equation, this is a key equation here. Okay. Almost you can come to one conclusion on for any machine torque equation. You can get it from this. This is the origin. Okay. And another one is, this is another interesting formula, Te minus TL is equal to J d omega by dt plus B omega. This is also another interesting formula for torque. Okay. So these two formulas, if you keep, things will be a lot more, interesting. Difference between torque angle and load angle in induction machine and synchronous machine respectively. You're asking a question, right? What is the torque angle? What is the load angle? Delta. That's a delta. Okay. So that dependence, you can call it as a power angle. There are a lot of other names. That's a long discussion. Okay. Now let's go to the next question quickly. Go for this. Stator flux with respect to rotor flux is stationary each other. Absolutely, Rajesh, you're right. You're right. I think there might be some emergency. Maybe I'm getting continuous calls. Not quite sure. Okay. Okay. कुछ कॉल आया तुम्हारा? नहीं. Okay. कॉल एक्टिव करना. ठीक. Sharad Chandra, only one C, okay, or C enter 10 times, you enter C. If you type C in a one row, our A will not catch. Okay, we didn't design for that purpose. C, 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 C enter, C enter, C enter you give, so your C will be registered multiple times. Okay. But yeah, response is amazing, guys. Okay, let's forget about whether it is right or wrong. It's a good response. Cool. Okay, time's up. Let's see. In a three-phase induction motor, the rotor field rotates at a synchronous speed. The rotor field rotates at synchronous speed with respect to stator. Only 40% answer correct. 56% people are saying this. Bhagavan. It is said it will rotate with respect to synchronous speed. Just now we have seen with respect to stator flux. See guys, this is lot of questions can be framed based on this simple concept. And this is popular series of questions. Again, it will confuse you definitely the way you got confused now. We have just now seen the relative speed between rotor flux and the stator flux is 0. We have seen that, right? So this, if I had to eliminate option, definitely I'll eliminate this option first. Why? We know rotor field and the stator field, they are stationary to each other. Okay, so this is wrong. And we know rotor, can somebody tell me now, what's the speed of rotor field and rotor? Rotor field and rotor, what is this speed? Tell me. What is this speed? What is the answer for this? Relative speed between rotor field and rotor. Or else, very good. This is slip speed. He answered in an amazing way. He could have said ns minus nr, but he used a nice word, technical term he has used, Raju has used, slip speed. Perfect, ns minus nr. Okay. Now, what is the relative speed between these two? What is the relative speed between these two? No dear, slip speed is different. Careful guys. Slip speed is different, slip is different. You cannot say slip. It is slip speed. There is a difference. Okay. Hi. Slip is ns minus nr by ns is slip. Okay. This is the relative speed between these two is nr. That's what the rotor speed will call. For the rotor speed, what is the reference? Reference is stator itself, stator stationary body itself. With respect to the stationary body, the rotor is rotating at nr speed. That's what this speed. Now the question is about, if this is nr speed and the speed between these two is 0 and the speed between these two is how much, tell me? Speed between these two is how much, tell me? I want a response. I want a response. Sir, can you please explain the concept again? Yeah, we'll come to that. So this is ns. This is ns speed. So now this speed difference is ns. This speed difference is 0. Now he's asking about this is with respect to ns what? Means answer is A simply. With logic also you can say that. Okay. Or else why to have all these points? That's why I said a powerful line. I said always remember that line. What is that line? Both the stator flux and rotor flux are stationary to each other. Okay. So that's Shashivardhan. I'm saying for your sake. Okay. So it's because both fluxes phi1, phi2, two fluxes must be present. They must be stationary to each other. Register that point in your brain. Okay. So these two fluxes, stator flux and rotor flux, must be stationary to each other. So if stator flux is rotating with respect to stator ns speed, rotor flux also will rotate at ns speed with respect to stator. Simple concept, same extending that line. Okay. So that's what you have to understand this question properly, this concept properly. This concept here is clear. I think this is going to be clear. I think you got a better insights now. Okay. And if it is not clear, guys, pay attention on this. In your lifetime, definitely you will see when you're writing a competitive exams, you will see definitely this question for sure. Out of 4 exams you write, in 3 exams, you will see this kind of a question regarding slip and all this stuff. Even in GATE also, GATE-like exam also, you will get this. Even normal exams also will get this. Why you'll get this? Because it's prone to get wrong here. People will do commit mistake here. There are high chances and it is very logical also. conceptual also. You can only answer these not by memorizing the stuff. You cannot memorize. If you memorize it, that's what you're doing, right? You marked it as option C. That's wrong. Based on your memory, you used it. You have not applied your analysis. With analysis, this will be the answer. Okay. So that's why I'm saying you have to pay some attention for this. It's easy. In our course, I explained this with the help of Trine example. We took Trine and animation is developed based on Trine so that it will be registered in your head. Anyways, that's a different story. Let's move to the next question now. Good guys, keep it up. Good participation for this question also. You're always ready, huh? Mostly, I think, I'm sure all of you guys try this, you will do something wrong. Okay. I don't think it's a tricky question. It's a really tricky question. And you guys got already trapped. Already, you guys got trapped already. Okay. So try again. Others you try. Now we got some right answers, but most of you done mistake for this. Okay. Now to check whether you're right or wrong, you need to register your answer. Okay, try to register that, then I'll explain this. See how logically the question is framed. Okay, except Sampath, everyone marked other answers. Only Sampath has registered B. Other people have registered for A and C. Okay, which are the following rotor quantity? So they're all rotor quantities. Okay, means frequency means don't think that it's a stator frequency, it's a rotor frequency because it's not mentioned here, but it is said what are the following rotor quantities. So these are all rotor quantities. Induced EMF, rotor induced EMF. So we know Fr is equal to S into Fs, right? And induced EMF, rotor induced EMF, or to be more precise, ER is equal to S into E2. Slip times of E2 is when it is stationary. Induced EMF of the rotor when the rotor is stationary. That's what E2. I think you got the point. Sampath has given the explanation also. See that explanation. Question is not clear to see. I think you need to change the settings here in the gear button. Go for gear and toggle to high quality. Okay, so there you change the settings. Your bandwidth net settings. Okay, I think you know that. And reactance XR, as a frequency is changing, rotor reactance also will change. Rotor inductance may not change, but the reactance is a function of frequency. Frequency changes, this also changes. Okay, so these three are the not right answers. Now you may say, sir, this is also not right answer then, because you know NR is equal to NS into 1 minus S. This is what the formula you know. So if slip changes, NR changes. So this is also not right answer. Apparently it seems like that. But Sampath has given a clarity also. Slip depends on speed, but not vice versa. Okay. Of course, mathematically, when you're rewriting this, you will rewrite like this. But originally speaking, slip is equal to, we have seen here in the previous questions, I think. Where is that? I think we raised it. Okay. Somewhere I think we have written that. Anyways, NS minus NR divided by NR. This is what the original equation. Now mathematically you can rewrite like that's a different story, but this is what the original equation means. Speed is independent of slip. Speed depends on what? Speed depends on some other parameters, mainly mechanical load and all. If speed changes, then slip changes. If slip changes, then these things will change. Okay, so let's give it up for all of you. You need to give your, that heart button, press it for Sampath. He's amazing. He has done that. Okay, so we blasted for him. Now it's your turn to blast for Sampath. Okay, you guys, yes, 100, 100, 100. We're getting some hundreds for Sampath. Good Sampath, keep it up. And no one else has marked for B, right? That's why I'm saying interesting logics. These are also good. See this. See, these are simple questions. They are not bigger questions, but these simple questions will help you to, get that pulse in the subject. Okay. Yeah, the origin of formula, if you don't know, you really miss it. The sequence, what is depending on what, you have to be very careful. Come on, everyone. Respond. Let it be right or wrong, it's okay. Let's not be afraid of being wrong. It's okay if it is wrong also. Let's participate. Try to know yourself whether it is right or wrong. Go ahead. If you're watching in the rebroadcast, not the live, you're looking at the question number. In the comment you give it. Question number 11, you mark your option. That's how engaging it should be. Okay, for every question number, you're seeing everything on the screen, right? Yeah, then not only for live sessions, for recorded sessions also you have to do this. Okay. Good. 50%, we got really mixed answers. A lot of mixing is done for this. Okay. Anyways, let's see what is so difficult in this. Oh, yeah. Nice concept. I told you, right? We are going to see some good concepts from this, from the next questions. The efficiency and power factor of squirrel cage induction motor increases proportional to its. Let's talk about one aspect. Let's talk about efficiency first. Just the curve of the efficiency. The efficiency curve not only for squirrel cage induction machine, for any electrical device, almost any electrical device, the efficiency curve is like this. Am I right? This is a load, be it load current or whatever. This will be the efficiency curve. If not like this, maybe it will stop here. It depends. Okay. So with the increase in load, efficiency is increasing up to this point, obviously. Beyond this, if you increase the load further, it will decrease. But this portion will be less. I just exaggerated a bit to here. It will be somewhere over here. But yeah, it's true. At some point, efficiency will decrease it. That's true. Okay. So in a way, I can say efficiency and this, yes, when load is increasing, efficiency increases. Okay. Coming to this power factor, I'm adding mechanical load. Careful with this. So which means transformer secondary, sorry, not transformer, I'm saying transformer, induction machine secondary, I can treat it like this, powerful equation, powerful diagram. This is R2, this is X2, this is R2 into 1 by S minus 1, or to be more precise, we just solve it a bit, you will get it as 1 minus S by S. This is what you'll get, this value. Okay. So now as load is increasing, speed reduces. Am I right? If speed is reducing, tell me what is happening to this previous equation. Speed is reducing. If speed is reducing, what will happen to the slip? Slip increases. If slip is increasing, it can maximum go up to 1. Maximum value it can go up to 1. So what is happening to the R2 value? This R2 prime value, this whole value. As speed is increasing, what is happening to its whole value? Yes? What happened? If this is 1, 1, 1, 0, it's infinity. Okay? So if it is 1, if s is equal to 1, in that case. So if s is equal to 0, this total one will be 0. Okay? Am I right? 0, infinity. No, it's infinity, it's open circuit. So if s is equal to 0, R2 prime, let's take this is infinity. If s is equal to 1, R2 prime, this is equal to 0. So slowly resistance is decreasing. It is said power factor is proportional to. Okay. Are we doing something wrong somewhere? I think it's all good. I'm missing something, guys. Anything wrong in the equations what I'm keeping here? S is equal to 0, R2 is equal to infinity, fine, this is equal to 1. This will be 0, which is like a short circuit, absolutely right. But with mechanical load, power factor is not going to increase, that's decreasing. Because resistance is decreasing. Huh? How come? I'm missing something? Any points from your end? Check it, guys. Did I miss something somewhere? It's not matching. As mechanical load is increasing, power factor according to this, it is decreasing. But it should not be the case because it's resistive in nature. I'm drawing more load. When I'm drawing more load, it's active part. Okay, it's active part. Yes, absolutely, it's active part. Active part is more, so power factor should improve definitely. Okay, because it's consuming more power, active power. Okay, so active part is but this equation is not saying that. This equation as in I'm saying R by Z concept. With that, R is not happening. Anyways, we'll see that. But let me tell you other way. Okay, let me fix this. So when under no load condition, let's take a no load condition. Under no load condition, suppose it is drawing some amount of current. This is a voltage, this is a current. This is a current. Some lagging nature. Okay, maybe a little more lagging. It's fine. Let's take it a little more lagging, close to 90 degrees. Let's take it this way. No load current I naught. Okay. Now when I'm drawing more mechanical load means the active part of the current. When I'm drawing active part of the current will be in phase with the voltage. So as this more and more, this in phase current is more and more when I'm drawing more mechanical load. Okay. So the resultant will be somewhere over here. If I draw even more current, resultant will shift even more like this. Okay, so power factor angle is reducing, so power factor value is increasing. That's the case. Okay, 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 yeah. So power factor is, we have seen efficiency also proportional to the load till this point obviously, and power factor also increasing. Cos phi is decreasing, power factor also increasing with the mechanical load. So the option is B. Any other feasible options? I don't think any feasible options. Now, any comments from your end? Any queries, any questions from your end? Okay. We shall move then to the next. Good. Let's go to the next question. Easy one. Looks like numerical type question, but logical question basically. You don't have to use calculator. If mechanical load increases, Sarat Chandra, yes, we'll come to that. We'll come to that. He has a nice point. Sarat Chandra has a nice point. So with Sarat Chandra's question, I think you will get some more clarity on these things. Beautiful question. All of you read this question once again. कहाँ पे लगाओ? क्या हो? Okay. Okay, time's up. Sharat Chandra, good question. We'll see that in a short while. And for this, we got mixed answers. Let's see this one. Okay, then we'll move to Sarat Chandra's question. I don't know how come you got option B, option C. Somebody's saying option D. Nobody said. Okay, option D also somebody's saying. Cool. Okay, let's see. A 6-pole 50 hertz 3-phase induction motor. Now, as an electrical engineer, without calculating, you should be able to say 6-pole 50 hertz means what is the synchronous speed? 1000 RPM. Without calculator, with over practice, you will get that. Or else, calculation also easy. NS is equal to 120 F by P. 120 into 50. 120 F by P is 6. This is 2 here. So 1000 RPM. So 1000 RPM is NS. Now it's an induction motor. We know induction motor will never operate at synchronous speed. So if you had to eliminate one option, this option you will eliminate. Okay. And at full load, it is a 950. At half full load means load is reduced. So speed will increase. Not 950. Speed is greater than 950. But less than 1000. So the only option which is matching is C. This is not a numerical type question. This is a concept based question. Okay. You have to apply the concept. You may think it's a numerical type, but it's not. Okay. Now let's come to his amazing question. Let me read out the question for you. Understand his point. Any confusion on this? I don't think there should be something on this. His question was, if load increases, mechanical load increases, slip increases. If slip increases, copper losses are proportional to slip into PG. You know this relation, right? If slip increases, copper losses increases. So losses are increasing. That's true. Mechanical load increases, losses are increasing. Now his point is, if losses are increasing, efficiency should decrease. That's what his point. Yes, you are correct. If losses increases, efficiency will decrease provided this output is constant. If this output is constant, if losses increases, efficiency decreases. But what is happened to the output? Output is also increasing. So numerator is increasing, denominator is increasing. Now it's after all a ratio, you have to take that. I'm not maintaining output constant, that is also changing. So if you plot that curve, try to recall the curve what you draw in your BTech during undergraduation. Efficiency curve you'll always draw like this. That's why till certain point it will keep on increasing, but definitely beyond that it will reduce. That case also will come. Okay. That's why efficiency is a double valued function. At one efficiency can get it at two loads. This is one load, this is another load. Okay. I think you got a clarity on this, dear Sharat. Okay. Shall we move on? Once again, good buddy. Next question, based on the same concept of powerful equation. Okay, what's a powerful equation? You have to keep this equation in your mind. Pg is to PCU is to Pmech is 1 is to S is to 1 minus S. It's not 8, it's S. This is a key formula to keep in your head. And like the way I said for slip, based on this formula, out of 4 exams, you will see this question in 3 exams. Okay, this formula is a powerful formula. Almost complete induction motor is governed by this formula. You can reach from anywhere to anywhere approximately. This is not exact formula, approximate one. Yes, we can handle this with this concept. What is approximation? Not approximation, this is exact one only. A little bit of approximation, fine. Okay, somebody's saying, see Rajesh, you need to register your option here, not the value. Others also try to register your options. What happened to others? What are you doing? Come on, register something. Easy one, not of maths. Don't think that it's math. It's not much of math. Simple logical thing. A rotor input of squirrel cage induction motor is running at slip. Slip is how much? 0.1. 10% means 0.1. 0.1 means 10% of the power is lost in the power losses, copper losses. In the copper losses, 10% is lost. So 900 watts, 100 kilowatts, you are giving it to the rotor. So PG is 100 kilowatt. Power lost is how much? Power lost is 10%, means 10 kilowatt is lost. So what is remaining? That's the output, mechanical power. So remaining is 100 minus 10 is 99. No, 90. So answer is B for this. So note this, that torque equation and this power equation, write it. And there is one more equation between power and torque. P is equal to omega T. Okay. Remember this also, powerful equation. Power is equal to omega, which is their angular speed, into torque. Okay. Next one, I think we shall go. So, Anna, I tried calling you today, but you didn't answer. I have a doubt and need one suggestion from you, Anna. Yes, Tami. Solo. Bolo. Tell me. Ask me. I think my team will see. You need to WhatsApp our team. Our team is actively active on WhatsApp. Okay. They will never miss any WhatsApp. We are WhatsApp first because a lot of people are having a shared WhatsApp thanks to web WhatsApp. So any WhatsApp, if not one, the other person will respond to you on WhatsApp. Based on that, they will arrange a call back. Okay. I got selected in CPWD. I have a joining in October, but I'm preparing for GENCO. I think maybe you just WhatsApp us. We'll reach out to you. Okay. By the way, are you the one who called in the midnight 12:30? Because my team member is saying that somebody called uh, there. Yeah, let's congratulate Srinivas first. Okay, congrats, dear. Next month beginning, you can expect the notification of GENCO. I think a lot of other institute also, they are, because it's high, the buzz is high. Why the buzz is high? How we are knowing buzz is high? It's because other institutes also, they are saying that, yeah, they got the information. It's not that we got the information, they also got the information. Means it's a solid, even come on, it's paper notification. Paper also it's there, personal contacts also they are saying that. So there is high chances. Okay, search on YouTube that GENCO, you will see how many people are talking about GENCO. More people are talking about GENCO, including newspapers, means there is a high chance. Okay, so come on, bring on your energy, start preparing. Okay. Uh, Anyways, you just Srinivas, WhatsApp us. I'm saying right. We will call. We'll catch you up maybe tomorrow. Okay. Coming to this, the 6-pole 50 hertz three-phase induction motor is running at 950 RPM. Okay. The rotor copper losses are 5 kilowatts. The rotor input is definitely not this. Okay. Rotor copper losses are 5 kilowatts, but rotor input is 5.3, only 3.3% output, mechanical output for such high copper losses. That's a shitty motor. So it cannot be the answer. Okay, neither, my intuition says, neither this cannot be the answer. Okay, but let's see if this is also answer. Motor efficiency is 50%, the worst efficiency of the motor. Okay, so it can never happen. So these two possibly are not the answers. Among these two, one of the answer, one is correct. What exactly is that? Let's see. What is NS here? NS is, we know 60 and 50 means it's 1000 RPM is NS. NS is 1000 RPM. And what is the slip value? NS minus NR, which is 950, which is 50 by 1000, which is 5%. Okay, means 0.05 per unit slip. Okay, now from our lovely relation, this relation, you can write PG is equal to PCU by S. Copper losses is 5 kilo, 5 into 10 power 3. And most of the students, they don't know about this kilo, mega, milli, micro, nano. They get confused on this also. Okay, so if you're also one of them, accept that first accept that yes, I too don't know, then study that, look at that, just a matter of few minutes. Okay, conversion from kilo to mega, all this stuff. And here it is 0.05. So 5 by 0.05, 5 gone, it gone up 100 into 10 power 3, so 100 kilo. Answer is A. Okay, it's asked for rotor input. What if the question would have asked for what is the mechanical power developed? Then simply, what's the answer? 100 minus a 5, which is 95 kilowatt. Bang, if it is mechanical power developed is the question. Okay, but the question is rotor input, so you need to be very careful on that. A little careful is enough, if not very careful. Okay, next question. We just got 5 more questions, I think. Just 5. ISRO PYQ, maybe, possibly. Good. A lot of people mark their options. 1, Time is up. Thrust, we'll call torque if it is a rotational machine. If it is a linear induction machine, don't get stressed the moment you see linear induction motor. So I don't know what is this linear induction motor and all. Just give it a thought, you will get this linear induction motor means it will not rotate, it will get the torque linear motion. That's we'll call it as a force, not a twisting moment of force, linear force. Okay, just a force. So now the thrust is developed by linear induction motor depends on just a torque. Take it as a torque. Okay, torque concept, here it is a thrust concept. Definitely rotor input, and definitely number of poles, correct? Because not just number of poles as well as the frequency, both will have an impact, which means synchronous speed. Because when I say synchronous speed, poles included, along with that frequency also included. Okay, so to be more precise, all three are correct, to be more precise. But it is MCQ question, not MSQ. So I would go for this because number of poles are included here. I don't have to worry about this. Okay, synchronous speed change, poles changes, number of synchronous speed changes. Okay, this is more appropriate among the options. So when you're having options, you should be very careful which one to pick it up. Okay, I think we are clear with this as well. No confusion. I'm concerned regarding the GENCO notification timing so that I can ask for extension. Show notification and release in October. I'll ask for extension. See, sir, there is no surety on anything. Unless you get that there is a high expectation, information, everything is there, that's for sure. Okay. So, if I say, yes, guarantee I will get it, I should be 100% sure on that. I'm not 100% sure on that. Notification, GENCO notification. From where you're bringing these ambiguity questions? It's not ambiguity questions, concept building questions. Okay, you should call them as a concept building question. That's an appropriate word. Okay, questions are everywhere, sir. You need to catch them. So if you are able to answer these so-called ambiguous questions, the regular questions will be very easy to handle. Okay, I think Srinivas, the point is clear. There is a high anticipation for that. When is your, when you call for this verification and all, is your certificate verification, everything is over? Srinivas? And you already selected there. You're appearing here. That's good. But there is a October 9th, he is joining. See, there is no problem for you to take a delay joining. You can delay, but what if it is delayed? Okay. Just WhatsApp, we'll talk about your case. Yes. A lot of people are saying option C. Let's check it out quickly. The double squirrel case motor. Wow, double squirrel case motor. I think you know that. Double case induction motor, or you can call double case induction motor or double squirrel case motor, whatever you can call, scores over a regular squirrel case induction motor. The drawback of squirrel case induction motor, normal plain squirrel case induction motor, is starting torque. If it is a slip ring induction motor, I can add some extra resistance to the rotor winding so that I can improve the starting torque. Okay, but in case of squirrel case, ends are short circuited. Now you may ask a question, sir, why don't you use this Squirrel case, and why you're using the squirrel case? Why not use a slip ring induction motor? If you use slip ring induction motor, yes, torque is controlled. Starting torque can be controlled, that's sure, that's for sure. But the maintenance problems are high for slip ring induction motor. Okay, and the running performance is better for this. Starting performance is poor, but running performance is better for this. So I want case rotor running performance, case rotor less maintenance feature, but slip ring motor starting torque feature. Amazing blend of these two is double case induction motor or double squirrel case induction motor. Okay, so speed regulation under normal operating conditions, yes. Starting torque, high efficiency under running conditions, it's not preferred over this just because starting torque. Okay, these are all true for squirrel case also. The only differentiating factor is C is a key factor. It is said, look at a question, it scores over squirrel case induction motor. What is the point which is giving high importance for this? Starting torque is a high importance. Okay, squirrel case rotor is robust, very good, very good. WhatsApp number, check the video description, you will get the direct link, click there, you will get it. The same calling number is WhatsApp number. Okay, or 998-993-998-2 is a WhatsApp number. WhatsApp on this. Next question. Let's go to the next question. Just now we have seen this aspect. Okay, it is preferred. We use because higher the resistance, higher the torque, starting torque. Torque means starting torque. Okay, so we'll use this outer case of high resistance to have higher starting torque. Just now we have seen that. Following question is that. Okay, very good. Next one. The starting, for starting purpose, for starting, there are different starting methods, but the motor, this motor itself is a special motor, where this is one of the commutation AC motors. Commutator, it will have a commutator also. Okay, it will have commutator also. So here we are feeding supply for starting purposes. In case of a slip ring induction motor, for starting purposes, what we'll do, we'll add resistance in the rotor. Okay, but for this we'll add three-phase supply will connect. Obviously to the stator anyways will connect. Okay, but for starting extra, what we'll do is we will connect a three-phase supply to the rotor through slip rings. We'll do that. Okay, next question. Shall I go for the next? How am I left? Just two more. I think they're easy ones. Pronunciate. There are different motors. Okay, one will call it as shaggy motor, discharge motor. Okay, there are different names, different pronunciations of that motor. Some people call it as a shaggy motor. In one professor has called it as discharge motor. Okay, so different people call it differently. During my diploma, I think my professor, he used to call it as shaggy motor. Yeah, different names. And I get to see, thanks to my diploma again, I get to use that motor also, both in MTech as well as diploma, but not in BTech, of course. Andhra Polytechnic used to be the best one. Nowadays, a couple of months back, 1 year back, I think, I visited Andhra Polytechnic where I studied my diploma. It's terrible. It's in a terrible shape. Uh, yeah, of course, we pulled up some money, we donated some money and all, but it's really terrible shape. But when I was studying, that's master class college. Okay, Andhra Polytechnic. Cogging in induction motor. See, we have a video on this also on YouTube, cogging of the induction motor. Cogging means what? The magnetic locking. You are giving input, you are giving supply voltage, but the rotor is not moving. Rotor is locked there only. Okay. Means starting torque is not enough. This happens mostly in case of squirrel case induction machines. Usually it won't happen for slip ring, because if it is a slip ring, you can increase the starting torque, you can make the rotor move. But if it is a squirrel case, you cannot really do that in a flexible way. So this magnetic locking will happen because of that. Magnetic locking is called as a cogging effect. Okay, that slot tooth difference will lock it. That's due to the number of slot tooth and number of rotor tooth are equal. Okay, number of slot tooth, and this is 0. What is this? Number of stator teeth and number of rotor teeth is equal to odd number. Number of stator teeth and number of is equal to even number. Number of stator teeth and number of rotor teeth is equal to 0. Number of stator teeth and number of negative number. I think there is something wrong in the options. Okay. So usually this happens when number of stator teeth is equal to number of rotor teeth. Okay. Stator and rotor are having same number of rotor and stator teeth, or maybe the integer multiples, then this problem will happen, cogging effect will happen. I think maybe a team might have misinterpreted or mistyped or do something, I think. Skewing. What is the effect of skewing on the starting torque? That's the next question. We'll go to the next question. I think we'll address this. I think for this is clear. These options, I think there's something fishy on this. Okay. This happens for mostly squirrel case when number of stator teeth is equal to number of rotor teeth, or maybe integer multiples. Okay, the clear concept is explained on our YouTube video on PiSquare channel. You can check that also. Okay, but this is some difference is missing or something. They have to say it's a difference between these two. I think the difference must be 0. Difference, if it is 0, then cogging will come. Okay, it's not must be 0. If difference is 0, then it will come. Now let's come to Raj's question. Yeah, it will be minus maybe. It happens. Typos. Last question. What is the effect of skewing on the starting torque? Because of skewing, regarding the skewing of the motor bars in squirrel case induction motor, which statement is false? Okay, false statement. Careful, which is false here? That's what is asked. So it prevents cogging definitely. To overcome this problem, either don't make the rotor stator ratio integer multiple, or if you had to make it integer multiple, skew it. Skewing it also will prevent the cogging, but it is asked for false statement, so let's take it. It increases the starting torque. Now let's talk about this, that's what Raju's question. It produces more uniform torque. Yes, this is right. Okay. It reduces the motor hum during operation. There is a hum sound because of the non-uniform torque. When there is a non-uniform torque, there is a hum produced. As the torque is uniform, it reduces the hum during the operation. That's also true. Now coming to the increase in starting torque, this is also true. Why? Because I'll tell you. I'm saying cogging torque is a magnetic locking torque, right? At the starting, you're having some starting torque as well as a cogging torque. Both will be there. Now what will happen? This starting torque will try to turn the rotor in one direction, but the cogging torque will block the rotor, will try to block the rotor. This is opposite torque. So the resultant starting torque will be, this is the resultant starting torque. Starting torque minus cogging torque will be the resultant starting torque. Now what is happening is, because of skewing, one thing what you're doing is, you are reducing this cogging torque, you're making it to zero. Okay, that cogging torque is too less. So resultant starting torque will increase. That's number one reason. Number two reason for increasing starting torque, of course, it's a small value. The second one, what I'm talking now, that will be a small value. Yes, due to increase in length. Very good, Raju. When you're skewing the slots, there is a little bit of increase in the length, a little bit, not much of increase. Okay, a little bit of increase in the length of the conductor. So that will lead to increase in the resistance. That will lead to increase in the starting torque. But these people would say that's very minimal. But yes, that's true. I'm not denying in that. But the main reason is, as the cogging torque is less, this resultant torque will improve. So to say, this is also right statement. Okay. Now you'll have to pick it of one. Which one I'll pick? Okay. If I have to pick one, but for me, all are correct. Okay. It's a tough call to pick one. It's really tough call to pick one. So I'll mark any one randomly. That's it. Okay. Because anyways, there is no answer in this, no false statement in this for me. So I'll randomly pick anyone. Then anyways, we have an option to counter these questions, right? Nowadays, thanks to this review system, like your DRS system in cricket, here also we're having a review system. We can review and get it done. Okay. Anyways, that's of today's session. Okay. And yes, as a resistor in the chat, he's saying a lot of ambiguous questions. This is how we have to deal with such ambiguous questions. What can be done? You can't avoid it, right? That's it. That's it for today's session. Have a good time, guys. Bye-bye. Anything to ask? It's already too late. Chalo, ठीक है. Bye-bye. Have a good time.